Welcome. This is the Math 159 Gould, Chapter 5, Section 2, fourth video about mutually exclusive events. So I'll explain what those mean, and it's going to be related to the things that we've discussed in the last this is the fourth video. So this will be related to the things that we've discussed in the last three videos, such as calculating events that have an or, calculating the probability of events that have an and theoretical probability. Okay, so what are mutually exclusive events? Mutually exclusive events can't occur at the same time. So to exclude means to preclude or to make another not possible. So they both make it so that the other can't happen. That's what it means. Okay, so for instance, let's say we're dealing with a normal 52 card deck, which has two colors, red and black, and four suits, diamonds, clubs, hearts, spades. The first two are diamonds and hearts are red, clubs and spades are black, and if you aren't familiar with them, the faces are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, ace. These are called the court cards, and these are just regular numbered cards. So let's say that your event A is drawing a 2 from the deck. Event B is drawing a 5 from the deck. These are mutually exclusive events. If you draw a 2 is different than a 5. If you draw a 5, you can't draw a 2. So these are mutually exclusive. Okay, so we want to calculate the probability of A or B. Luckily, there's a formula if your events are mutually exclusive. It's rather straightforward. It's the probability of A plus the probability of B. So it's really easy to do that. We go over here and we're like, hey, what's the probability of drawing a 2? Well, there is a 2 from each of the four suits. So there are 4 2s. And how many cards are there? 52 cards. That's the sample space. Now let's talk about the probability of event B. What's the probability of drawing a 5 from the deck? Well, same thing. There is a 5 for each of the 4 suits, so 4 out of 52, which is 8 out of 52. We'll have the computer calculate it for us. 8 out of 52 equals 0.1538, which is 15.4%. So what's the probability of drawing a 2 or a 5 from the deck? Really easy to calculate. You just add the individual probabilities because they are mutually exclusive. Okay. Let's do one that's not mutually exclusive. What if they aren't mutually exclusive? This is going to be more like the example we did up here with the OR, where we made a Venn diagram, right? This event here, the first die is even and the sum is greater than or equal to 9. Those are not mutually exclusive because they can occur together. There were 6 events that satisfied A and B. So the mutually exclusive means that this overlap here would be 0 or nothing, yeah. So luckily there's also a formula for if they aren't mutually exclusive. But let's set this up. Let's say our court card, let's say that event A is drawing a red card. Event B is going to be drawing a court card. Remember, a court card is jack, queen, king, ace. So what's the probability of drawing a red card or drawing a court card? Well, there's a formula for this. You can do the probability of A plus the probability of B minus the probability of the overlap. Okay, so what's the probability of drawing a red card? Well, there are 4 suits, and 2 of each of the suits is red or black. So half the cards are red and half the cards are black. So out of your 52 cards, 26 of them are red. Okay, what's the probability of drawing a court card? Well, there are 1, 2, 3, 4 court cards for each suit, and there are 4 suits, so there are 16 court cards. Okay, now we need to find the probability of A and B. Well, okay, there are 26 red cards. Sorry. Let me cut my throat. Alright, so let's talk about probability of A and B. 52 on the bottom. Okay, so there are 26 red cards. And there are 4 times 4, 16 court cards. Now, we know that of these 16 court cards, 4 of them are diamond, 4 of them are diamonds, clubs, 4 of them diamonds, clubs, hearts are hearts, and 4 of them are, can't really draw it very well, spades. But anyways, these are black, so 8 of them are red. So there are 16 cards, are court cards, half of them are red, which means that there are 8 in total. So 8 of these 26 red cards, you get 8 right here. Okay, so now what can you do? You can do 26 plus 16 is 30, 42, 42 minus 8 is 34. And if you calculate that, 34 over 52 is 0.6538, which is 65.4%. So there's a 65.4% chance of drawing a red card or drawing a court card. Now I quickly want to show you how this is related to the Venn diagram. So I'm going to draw my 2 circles. Here's one. Here's my second. And let's quickly put a box around it. Okay, so the one on the left is going to be A, the one on the right is going to be B. So in total, there are 52 cards. So all the things in the areas should add up to 52. Okay, so A is a red cards. So in total, so I'm going to give names to this. I'm going to call this one X, I'm going to call this one Y, I'm going to call this one Z, and I'm going to call this one W. So A is Y plus Z. And Y plus Z in total needs to be equal to 26. B is Z plus W, and in total those have to add up to 16. And we know that X plus Y plus Z plus W is equal to 52. Okay, now Z, remember, is the overlap. How many cards are both A and B? Well, we figured out that that was 8. There are 8 cards in here that are both red and a court card. So A is all the red cards. If there are 26 cards in total that are red and 8 of them are in the overlap, well, how many have to be in the Y area? So 26 minus 8 is 16, right? There are 16 cards that are red but are not court cards because 16 plus 8 has to add up to 26. Okay, wait. Did I subtract that improperly? I meant 18. My bad. I can't do 26 minus 8. Okay. Z plus W has to be equal to 16, so this one has to be 8. Now, Y plus Z plus W, that's 18 plus 8, which is 26, plus another 8 is 34. Well, what's 52 minus 34? I can't do that in my head right now, so let's do 52 minus 34. 18. So there are 18 cards that are not red cards and they're not court cards. So you can see that the numbers actually line up here if you do it like this. The probability of A or B is going to be 52 because that's the sample size. Now, how many things are A or B? Remember we discussed about how A or B is the stuff in Y plus Z plus W. It's the stuff that's in any of the circles. and that is 18 plus 8 plus 8. If you add that together, you get 26 plus 8, which is 34. And notice 34 over 52 is exactly what we got from this formula right here. Okay, and that is the end of the video. Thank you.